Okay, so here's the second review. So this is the one that does not say no calculators, show your work. So the other one, the one that does not have a space for your name and PSID. That's the review that I'm going through. So, number one, it gives us points A, that's number one, which is 1 minus 2, 1, B, which is 3, 2, 2, 2, and C, which is minus 2, 1, minus 5. Okay, prove that A, B, and C are vertices of a right triangle. Well, if they're vertices of a right triangle, then the vector, two of the vectors need to be orthogonal to each other. Okay, so let's figure out all the vectors. So we have the vector AB, which is 2, 4, 1. We have the vector AC, which is minus 2, that's minus 3, 3, minus 4. And then the vector BC. So that's minus 2, that's minus 5. Let's see, so we have, yeah, 1 minus, minus 1, and minus 5, minus 7. Hold up, is that right? So I have C minus, something's not adding up here. One of these is wrong. Because I should be able to add AB to BC and end up with AC. So 1 plus minus 4 is not negative 7. What did I do wrong? Okay, so AC, this should be minus 5. This is minus 6. Okay, so are two of these at right angles to each other? Well, let's start computing. The dot product and see if any of them are 0. So AB dot AC, this is minus 6 plus 12 minus 6 at 0. So yes, this is part of a right triangle because AB and AC are at right angles to each other. So determine the length of the hypotenuse. Well, if these are the two legs of the triangles, because they're at right angles, the hypotenuse is this vector BC. Right, so that's going to be norm of BC, which is square root 25 plus 1 plus 49 is square root 75 equals 5 root 3. Okay, find an equation for the sphere that has the hypotenuse as the diameter. Oh boy. So that's not too bad. Okay, so we want a sphere. And it has the hypotenuse, this vector BC, as its diameter. So that means on one side and on the other side is B and C. So that gives us, that's easy to find the midpoint, and we already know the length, so half of that is going to be the radius. So let's find the midpoint. That's just going to be the average of B and C. So B plus C over 2. That's going to be the midpoint. So this is 1/2 of 3/2 and minus 3/2. Okay, so that's the midpoint, and we know what the radius is because it's half of that. So we have the equation of the sphere is x minus 1/2 squared plus y minus 3/2 squared plus z plus 3/2 squared equals 5 root 3 over 2 squared. Okay. Okay, that's part B to question 1. Okay, so B, it gives us A is 2I minus k, B is equal to 2I plus 3j minus k, and C is equal to minus I plus 3j minus 2k. And it says calculate, so 1, 3 times 2a minus b plus c. So the first thing that I would do is not just take these and plug them straight in. Okay, actually, first thing I would do would be to write them as personally, I find it easier to do this as column vectors. So A is 2, 0, minus 1. B is 2, 3, minus 1. And C is minus 1, 3, minus 2. Okay, next I simplify this as much as possible. I only want to have to use each of these vectors once, if possible. Okay, so this is going to be 6a minus 3b plus 3c. So that's 6 times 2, 0, minus 1, minus 3 times 2, 3, minus 1, plus 3 times minus 1, 3, minus 2. That's going to be 12, 0, minus 6, plus minus 6, minus 9, 3. That's 9. And then we have plus minus 3, 9, minus 6. And we add them all together. Or I add the first two first. We have 6 minus 9 minus 3. I end up with 3, 0, minus 9. Okay, find the projection of C onto B. So C is, well, this is going to be C dot B over norm B squared times B. Okay, so that's going to be C right here, negative 1, 3, negative 2, times 2, 3, minus 1. C is minus 1, 3, minus 2, dot 2, 3. And the norm of B, so that's going to be square root, nope, because I'm squaring it. It's going to be 4 plus 9 plus 1 is 14 times the vector 2, 3, minus 1. Okay, so we have minus 2 plus 9 plus 2, those cancel. So we have 9 over 14, so we end up with 18 over 18 over 14, that cancels to just 9 over 7. And then we have 27 over 14. And we have negative 9 over 14. Okay, let me copy down. We have A, which is 2, 0, minus 1, and B, which is 2, 3, minus 1, and C, which is minus 1, 3, minus 2. Okay, it says determine a unit vector in the direction of A cross B, or in the direction of B cross A. All right, so we compute B cross A. All right, so we have I, J, K, plus minus plus, 2, 3, minus 1, 2, 0, minus 1. So that's going to be minus 3, I, minus, that's minus 2, plus 2, that's 0. And then we have 0, minus 6. Okay, so we have minus 3, minus 0, minus 6. And then we need to normalize this. So the norm of B cross A, that's going to be square root of 3 squared plus 6 squared. That's 9 plus 36, which is 54. That's going to be 3 root 5. Sorry, that's 9 plus 36 is 45, which is 3 root 4. So we normalize. So we have B cross A over norm B cross A. That's going to be negative 1 over root 5, 0, 2 over root 5 with a negative. There's my answer. Okay, determine the volume of the parallelepiped with A, B, and C as its sides. So that's going to be A dot B cross C, or even C dot B cross A will also work. And this is great because we already know what B cross A is, right? It's minus 3, 0, minus 6. So now I just do the cross product of B cross A with C, do the dot product between those two. I have minus 3 times minus 1, that's 3, plus 0, minus 6 times minus 2, that's plus 12. So this is 15. All right, and that concludes problem 1. Oh boy. Okay. Problem 2. We have the plane 3x minus y plus 4z equals 3. And we have the line x minus 1 over minus 2, y equals y plus 4 over 2 equals z plus 3 over 2. And the point A, which is minus 3, 0, 5. Okay, first question. Determine whether P and L are parallel. So P is a plane and L is a line. So they're going to be parallel. So what does it mean for them to be parallel? Okay, so I have a plane and I have my normal vector sticking straight up out. And I have my line coming along here. If it's parallel, then it's the same as if I was to shift it down and it was in the plane, meaning that the direction vector is going to be at 90 degrees to the normal. So the normal is 3 minus 1, 4, and the direction vector is going to be minus 2, 2, 2. Okay, so these the line will be parallel to the plane if the dot product between these two, n dot d, is 0. Is it? Well, let's find out. So I have minus 6 minus 2 plus 8 equals 0. Yes, it's parallel. B. Okay, determine whether A lies on L. Well, we just plug it in, right? So here we have minus 4 over minus 2 equals 0 plus 4 over 2 equals 5 plus 3 over 2. All of these are equal, right? This is 2, this is 2, this is 2. Yes. Okay. So determine the parametric equation for the line M that passes through A and is perpendicular to P. So if it's perpendicular to the plane, that means that the direction vector is going to be the same as the normal. And we know the point. Right, so M, that's going to be our point that it goes through, 3, 0, 5, plus t times our direction vector, which is going to be the same as the normal. It says find the parametric equations. So let's write that as x of t equals 3t minus 3, y of t equals minus t, z of t equals 4t plus 5. Okay, D. Find the point of intersection of M and P. Shouldn't it just be A? Okay, so I'm going to go back and look at part B because it says determine whether A lies on the line L. If it does not, if it doesn't, find the distance from A to L. All right, so I have x minus 1 over minus 2 equals y plus 4 over 2, z plus 0 over 2. Okay, so we plug in 5, we get 8 over 2 is... Oh, I see. Okay, so no, I made a mistake. This is not on the line. Okay, so I need to go back. Okay, going back to part B. Nope, doesn't want to erase. Okay, whatever. Okay. That should actually delete. There we go. Okay, so my bad. I should have actually simplified these. This means that we have 2 equals 4, which is not the case. So that's what I got when I just plugged these points in. So this point does not lie on the line. Okay, so then in that case, we need to find the distance from A to L, to the line. Okay, so we have a line. We need a point on the line. This is A. We need a point on the line. And then I need to find the projection here. And then from there, I compute the orthogonal projection, and I compute the norm of that. Okay, so my point on the line I can read this off straight from here. My P is going to be 1 minus 4 minus 3. So the vector PA is, so it's A minus P, so that's going to be minus 3 minus 1, that's minus 4. 0 minus 4, that's 4. And 5 minus 3, that's 8. Okay, so that's this vector right here. Now I need to do the projection of PA onto my direction vector. So that's going to be PA dot D over norm D squared times D, which gives me, so that's 8 plus 8 plus 16 over, that's going to be 4 plus 4 plus 4 times minus 2, 2, 2 equals 8 and 8 is, so that's going to be 32 over 2 root 3 minus 2, 2, 2. Cancel, 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 cancel. Is going to be 32 over root 3 negative 32 over root 3 and 32 over root 3. So that's the projection. Now I need the orthogonal projection, meaning I do PA minus the projection of PA onto D. Okay, so I have, I feel like I didn't compute something correctly. Ah, because that's supposed to be squared on the bottom. This is supposed to be 4 plus 4 plus 4. There's no square root there. So this is going to go away. Okay, so 4 plus 4 plus 4, that's 12. That's better. Okay, so that still cancels. We get a 6. That cancels for a 3, and this becomes a 16. We get minus 16 over 3, 16 over 3, 16 over 3. Okay, so that's much better. So now I can do minus 12 over 3 minus 16. And then I have 12 over 3 minus 16 over 3.
Mic off. Mic on.
And then I have 24 minus 16 over 3. All this to give me, so that's 4 over 3. That's minus 4 over 3. And I have, that's going to be 8 over 3. Okay, almost done. Now all I need is the norm of this vector. Okay, so that's going to be square root of 4 over 3 squared plus 4 over 3 squared plus 8 over 3 squared. So that's square root. I can bring the 3 squared, I can factor a 3 squared out of each of these, and if I bring it out, I get 1 over 3. Now I have 4 squared plus 4 squared plus 8 squared. So that's 2 times 8 squared, so that's going to be 8 root 2 over 3. Okay, so that's the distance from the line, from the point to the line. Okay, So these make a lot more sense now. So I have a plane and a point for the line that passes through A and is perpendicular to P. Sorry, determine the parametric equation for the line M that passes through A and is perpendicular. Okay, so if it's perpendicular to M, that means that the direction is the same as the normal vector, and it passes through A, so that's our point on the line. So this is actually really simple. M is, so A is minus 3, 0, 5 plus T times our normal vector, the vector that's normal to the plane, which is 3 minus 1, 4. Okay, and it says determine the parametric equation, so I write this as x of t is 3t minus 3, y of t is minus t, and z of t is 4t plus 5. Okay, find the point of intersection of M and P. Well, so I know if this is x, y, z, so, and I know that the plane is the equation, where'd it go? 3x minus y plus 4z equals 3, then I can just plug each of these in for x, y, and z. So I have 3 times 3t minus 3 minus y times, sorry, not minus y, minus, so it's minus y, which is minus t, plus 4 times 4t plus 5 equals 3, and I'm going to solve for t. 9t minus 9 plus t plus 16t plus 20 equals 3. So that's 26t. So that's minus 9, that's plus 11 equals 3. 26t equals minus 8. T equals minus 8 over 26. That can simplify to 4 over 13 negative. Let me double check this real quick. So I have 4t plus 5. Right, this is my direction vector, 3 minus 1, 4. Okay, that's fine. And then, so that's my direction, and my point on the line is minus 3, 0, plus 5. Okay, so I plug that in. 3t minus 3 minus t, 4t plus 5. So that's 9t minus 9 plus t, 16t, 20 equals 3. Okay, I'm going to say that's good. So now the point on the line, the point where this is just going to be when I evaluate each of these at this point. So x is going to be 3 times minus 4 over 13 minus 3, which is, if I put this over a common denominator, I have minus 12 minus 39 over 13, which is 40 minus 52, negative 4. Y, which is minus 4 over 13, which is just 4 over 13. And finally, z, which is 4 times minus 4 over 13 plus 5, so that's minus 16 over 13, 50 plus 65 over 13. So if we subtract, that's going to be 40, 39, 39, 13, which is 3. So all that said, the point of intersection is going to be minus 4, 4 over 13, 3. Okay, moving on to problem 3. Okay, given the planes P1, which is x plus 4y minus z, equals 10. P2 is 3x minus y plus 2z equals 4. So I'm probably going to need the normals. I'll go ahead and write them. Okay. Determine an equation for the plane that contains, oh, and it gives us the point A, which is minus 2, 1, 0. Determine the equation for the plane that contains A parallel to P1. So that's going to be n1 dot x, y, z, right? It's going to have the same normal, and that's going to be n1 dot a. So this is going to be x plus 4y minus z equals, so that's a minus 2 plus 4, right? Minus 2 plus 4. So a is going to be x plus 4y minus z equals 2. Okay. B, determine whether A lies on P2. If not, find the distance. So B, we just plug it in. We're plugging A into P2. So we have 3 times minus 2 minus 1 plus 0. That's not 4. So we need to find the distance from this point to the plane. And again, we have this picture. So we have this point way up here, and we have the normal sticking straight out. Right? If I wanted to find this, I need a point right here. That's not hard to find. I have my A, and I could do the projection onto N and figure out that distance. Thankfully, we already have a formula. That's where it's AX plus BY plus CZ plus D over square root of the normal. Okay, so real quick, we're dealing with P2. Remember, I need to move this over to this side for it to count as this D, otherwise I'm going to have a wrong sign. So this becomes 3 times minus 2 minus 1 plus 0 minus 4 over square root 9 plus 1 plus 4. That's minus 6, minus 7, minus 11 over root 14. Okay, C. Determine whether P1 and P2 are parallel. If not, find the symmetric form of the line of intersection. So this is not a multiple of that. Hopefully that's easy to see. Right, so if it was, this would be 3 times whatever this was, if we just look at the x component. But it's not. We go to 4, and 4 times 3 is not negative 1. So they're not parallel. So we want to find the equation of the line that goes through them. So the way we do that is first we need a point on the line, and we also need the direction vector. Well, the direction vector is going to be orthogonal to n1 and n2. So I'll do that first. So n1, I'm going to copy this down. Okay, so the direction vector is going to be n1 cross n2, which we have I, j, k, plus, minus, plus, 1, 4, minus 1, 3, minus 1, 2. Okay, so we have 8 minus 1 I hat minus 2 plus 3 j hat plus, so we have minus 1 minus 12 k hat. So that's 7 minus 5 minus 13. Okay, so that's our direction vector. We also need a point on the plane. Well, we can just pick, oh sorry, we need a point that's on both of them. So let me copy these down. So we need a point that's on the planes x plus 4y minus z equals 10. And then we have 3x minus y plus 2z equals 4. And then I need a third equation if I want a point. I'm just going to pick z equals 0. And then we'll solve for x and y. So if I do this, right, I have x plus 4y. Let me put this over here. I have x plus 4y equals, this should have been 10, equals 10. And here I have 3x minus y equals 4. I'll multiply this one by 4 and add. So I have 13x, that's 0. Multiply by 4, I have 16 equals 26. X equals 2. Okay, plug that back in here. So I have 6 minus y equals 4. And we have y equals 2. So we know that the point on the line is 2, 2, 0. And then we had our direction vector right here, plus t times 7 minus 5 minus 13. And that's our line. And it said it wants it in symmetric form. So let me go ahead and write it out in parametric form first. Actually, you know what? I can go ahead and write this straight in symmetric form. So I have x minus 2 over 7, y minus 2 over minus 5, z over minus 13. Symmetric form of the equation of the intersection of those two. Okay, and the final question is determine the angle between P1 and P2. So again, I have N1, which is 1, 4, minus 1, and 2 I have is 3, minus 1, 2. So the cosine of the angle between them is going to be N1 dot N2 over norm N1, norm N2. So N dot N1 dot N2, that's going to be 3 minus 4 minus 2 over, that's going to be 1 plus 16 plus 1, that's root 18, 3 root 2. And on this one I have root 14. Yeah. So this is going to be minus 3, 3 cancels, 1 over root 28. No, that can simplify. That's 1 over 2 root 7. Okay, number 4. f of t equals 2t plus 1 I minus cosine of pi t j, and g of t equals t squared I plus 3j. And I'm going to assume that these are just have a 0k component. Okay, limit as f goes to 3. So limit as f goes to 3, or as t goes to 3 of f. That's just, I just plug that in. So this is 6, 7, that's going to be 7. Here, if I plug in 3, that's cosine of 3 pi, which is the same as cosine of pi, which is negative 1, so that's going to be 1, 0. So that's the first part. Okay, the next part is do the product rule. Page pinned. The product rule, yeah, just in general. Okay, so we have f of t dot g of t prime. That's going to be f prime of t dot g of t plus f of t dot g prime of t. So here, f prime of t, that's just 2 minus pi, derivative of cosine is negative sine. And g prime of t is 2ti plus 0j. Okay, so f prime dot g, that's going to be, let me write this in component form. This is 2 pi sine pi t, 0. This up here is t squared 3, 0. And this right here is 2t, 0, 0. Okay, so f prime time dot g, so that's going to be 2t squared plus, nope, yes, plus 3 pi sine pi t. That's his first term, plus f dot g prime. That's just going to be 4t squared plus 2t. That's it. So this is 6t squared, 6t squared plus 2t plus 3 pi sine pi t. That's all for that one. Okay, we didn't really talk about velocity and acceleration, so I'm going to skip those next ones. And this last one, let's see, I guess you could determine the unit tangent vector. Oh, no, okay. So number 5. Number 5, so we have find the scalar parametric equation of the line tangent to C where t equals 3. So here we have r of t is 2t t squared 1/3 t cubed. Okay, so find the scalar parametric distance. So let me find the tangent line. So the tangent line is r prime, which is 2 2t t squared. Okay, and I'm interested in the point at t equals 3. So r prime at 3 is 2, 6, 9. Okay, and I also need a point on this tangent line. Well, specifically, this is the tangent line, so it barely touches r when t equals 3. So I also know that r of 3, this is going to be the point that I want. So this is going to be 6, 9, 9. Okay, so my tangent line is going to be my point on my line, 6, 9, 9, plus t times 2 times my direction vector, the tangent vector. Okay, and let me just write it as 2t plus 6, 6t plus 9, and 9t plus 9. I'll leave it there. Okay, find the length, I skip it. Determine the unit tangent vector and the principal normal vector. Okay, so we know that, let's see, so this is b. R prime of t is 2 2t t squared. Okay, so I can do the norm to find the unit tangent vector. So that's going to be 2 squared plus 2t squared plus t squared squared, which is what? 4 plus 4t squared plus t squared squared, 2 plus t squared, 2 plus t squared. Okay, so this tells me that my unit tangent vector is going to be 2 over 2 plus t squared, 2t over 2 plus t squared, and t squared over 2 plus t squared. So that's my unit tangent vector. I still need to find the principal normal, which I will do by finding the derivative of this unit tangent vector. Okay, so the normal, the principal normal at t is going to be, so that's low d high minus high d low times 2t over 2 plus t squared squared. And then we have low 2t 2 plus t squared, 2 times 2 plus t squared minus 2t times 2t over 2 plus t squared squared. And finally we have low as 2t 2 plus t squared minus t squared 2 plus t squared 2 plus t squared. Okay, and then I can simplify this a little bit. So I get minus, you know what, first let me just factor at the bottom. It's a function anyways. Over 2 plus t squared squared times minus 4t. So here we have, it's going to be minus 4t squared, so we're going to have minus 2t squared plus 4. And here we have 4t, here we have 2t cubed Oh, so we have, what is this? 4t, 2t cubed, minus 2t squared, minus t to the 4. Okay, so let's go ahead and write that out. So I have minus t to the 4. Oh, hold on. No, that should be high, d low, 2t. Okay, that's better. So that becomes, that cancels out, so we just have 4t. And that is my principal normal vector. Okay. No osculating plane. Moving on to number 6. So we have r of t is cosine of t plus t sine of t. Then we have sine of t minus t cosine of t. And then last one is what? Root 3 t squared. Okay. Find the unit tangent vector and the principal normal vector. So the tangent vector, that's going to be not fun. Okay, derivative cosine is sine t. Then I have to use the product rule, so I do t times derivative of sine is cosine plus sine t. Okay, and then here I have derivative of sine is cosine. And then I do the product rule again, minus t derivative of cosine is negative sine. And then minus cosine of t. And then derivative of this, we get root 3t. Oh boy. Okay, so does that cancel out? Yeah. So that cancels. These don't. So we have sine squared of t plus t cosine of t, t sine of t, root 3t. Okay, I think this sine squared was supposed to cancel out somehow. Let me make sure I copied everything down right. Oh, derivative of cosine is negative sine. So yeah, that actually cancels out. Okay, so now I can write this as t times cosine t sine t root 3. Okay, so the norm of r prime of t is going to be absolute value of t times the norm of this. Okay, so that's absolute value of t times, so it's going to be square root of derivative of cosine is negative sine squared t plus cosine squared t plus 3. So that's 1 plus 3 is 4, so that's 2t. So finally we get that our unit tangent vector at t is going to be cosine over t plus over 2. And let's just assume that t is bigger than 0, so we don't have to worry about absolute value. Okay, so plus sine of t, sine of t over 2t, minus cosine of t. No, I'm doing this wrong. I'm doing this wrong. I need to divide the derivative, the tangent vector, by t. And what just happened? There we go. Okay. So this is my tangent vector. Divide that by 2t, and I get cosine of t over 2 sine of t over 2 root 3 over 2. Okay, that's a lot easier to take the derivative of, because now when I take the derivative to get the normal, it's going to be a lot easier. Okay, so now the normal, the principal normal, that's going to be derivative of cosine is negative sine, derivative of sine is cosine, and that's going to be 0. And that is my principal normal vector and my tangent vector, or unit tangent vector. Okay, and that's looks like all the questions from this review that will be on the test.